Okay, we are live streaming. Let me just check to make sure. Okay. Everybody should be able to hear us right now, which is probably going to be disconcerting for people. Don't worry, we see you guys. Oh, wait. Are you able? Oh. Hi, everyone. Okay.
Down in front.
Down in front. All right. Hi, everybody. You guys can see me right now. The real question is whether or not. So, usually I would actually have a camera pointing towards the crowd. But we have a couple people here today. Thank you guys for coming. What is it?
What are you using to stream?
I'm using OBS.
Also, I don't see your live stream. Are you like live yet?
Oh, no, it's on my Discord.
I'm such a boomer.
The link is on Discord. The Discord in the basement, go to space.
Yo, THC still legal in Texas.
Oh, yeah, we're live. All right. So we have one watching, and I believe that's just me. Okay. Cool. Let's move it this way. Okay. I'm going to stand like right here. Let's see how many seconds of delay. Okay, so it's about a 15 second, 20 second delay here. All right, perfect. Okay. Cool. We're starting 3 minutes late? Not really. 3 minutes late. That's pretty good. Go ahead and tell me in chat if you guys can hear me or not, if the audio's okay. We're hoping to have no more technical difficulties. It's going to be a pretty short presentation today, but we're just going over Artemis 2, so it's going to be short and sweet. All right, let's see here. Let's go with the live stream. Yeah, all right. Okay. I'm also going to have to negotiate the fact that I'm watching the live stream right now on YouTube to make sure that everything's fine. And it's delayed by like 20 seconds.
I'm watching it on here. You're fine.
Oh, you're the second person watching it. Okay,
yeah,
cool.
I'm
okay.
trying not to post anything annoying.
Okay, so I guess thank you guys for coming. We're going to do a little quick presentation about Artemis 2 today. We're returning to the moon. Artemis 2 is scheduled to launch this coming week, Wednesday, April 1st. The launch window opens on Wednesday. We'll get to that in a moment. But welcome. Prepare for launch. My name is Alejandro. A little bit about me. I went to Texas A&M. I got a major in architecture and a minor in astrophysics. I love NASA. I love space. I love doing education outreach. I'm the former vice president of Students for the Exploration and Development of Space on Texas A&M's campus. It's probably a little bit far removed for me to be using that still, but you know what? I'm proud of it. It was a great organization, and I suggest anybody who is interested in space and is a student in college or in high school to be looking to try and join that organization and volunteer and try and make it into an amazing organization, an amazing chapter on whatever campus you're on. So, a little bit more about me. I like space, obviously. This is a picture of me over in Boca Chica down in Brownsville, right next to South Padre Island. That's where SpaceX built their launch pad, their launch facility, Starbase, where they're building all of the starships, the super heavy boosters, etc., etc. On the bottom right, we've got a picture of the SR-71 over at the California Science Center. I love airplanes, obviously aerospace, both space and airplanes. The SR-71 is recorded as the fastest known air-breathing piloted aircraft. So there are a couple aircraft that are faster. Technically, the X-15 rocket plane had a pilot, but it worked off of a rocket, the XLR-99. If you guys want to go down a rabbit hole, that's a cool airplane. and the X-43 was a hypersonic Mach 9.7 aircraft that flew at over 100,000 feet, but it was a drone, so no pilots. This flew at over Mach 3.5. Technically, that's the top speed that we know of. No one actually knows the top speed. It's classified. But it had either one pilot for the A-12 variant, which was built for the CIA specifically, or two pilots, or two cockpits, one for the reconnaissance officer managing the cameras, and one for the pilot. And it flew at around 80,000 feet over the Soviet Union and anywhere else that the United States needed to photograph. Amazing airplane, developed in the 50s and 60s with titanium and all a bunch of different really cool technical innovations that allowed it to fly higher and faster than basically any aircraft before or since. Incredible. Top right is a representation of the fact that I love cars. That is in the Peterson Automotive Museum in Los Angeles. It is a Ferrari 250 GTO 1962, which currently holds the record as one of the, or I don't believe it holds the record anymore because I believe a Mercedes took it, but it used to hold the record as the most expensive vehicle ever sold at auction at around 70 million euro, not dollars, euro. And there are only 32 examples that exist today. Every single one that was ever made still exists. They were handmade by Ferrari back in the 60s to win the 24-hour of Le Mans and various other races. They are extremely, extremely rare and in the collections of people like Ralph Lauren and several other billionaires, obviously. A car costing 70 million euro, you're not gonna have that unless you have some serious zeros on your bank account. So we're gonna go straight into it, Artemis 2, and this is the mission that we're here to talk about today. I've got a little bit of a video for you guys. Ready?
We want to know what's out there just beyond the horizon.
Amazing live views from the spacecraft.
Coming back to Earth, say we were doing like 5 or 7 miles. 7 miles a second. Those are just not numbers that humans generally think about.
We were always going to the moon.
Pushing ourselves to explore is core to who we are.
3.
It's in our nature.
1.
It's a part of being a human.
And liftoff! 6 million pounds on the pad. 250,000 miles.
Boosters have separated.
When humanity sets big goals, we can accomplish extraordinary things.
All right. That was a quick little video made by NASA to kind of be the...
What President Kennedy said was, we choose to go to the moon and do other things.
Yeah, there we go. Okay. Now, the real problem is the fact that I don't think this live stream is showing all of the... what is it? Display, window capture... there we go. Okay, so we're gonna skip over this. Oh.
Yeah, it's still.
Yeah, the live stream is kind of borked right now. So, we're just going to go with the big video then. Okay, so Artemis 1 was our first... okay, I'm going to wait until... We're going to edit this out in post. We're going to fix it in post, right?
It's live.
Yeah, but we'll fix it in post for the VOD, the video on demand people, all right? All right, so it is working. Okay, so Artemis 1 was the first flight. We're going to go ahead and forego the video just to keep any problems from arising from there. But basically, Artemis 1 was back in 2022, right? We were talking about this before the presentation. This was November of 2022. It was basically a test flight of the vehicle. It was we just send it out, have a little fun with it, and then it comes back. And basically, it went out directly into a translunar injection orbit, a trajectory, over to the moon, and then it hung out around the moon for a little while. Let's see, 6-day duration for the retrograde orbit. So it's a distant retrograde orbit, which is a different orbit than the Apollo spacecraft did. Apollo spacecraft went into low lunar orbit so that the command module could detach the lunar module, or the lunar module could detach from the service module and then drop down and then come back up. This spacecraft obviously didn't have a lander, so it was just hanging out and doing a nice big round around the moon. It drops in close and then comes back really far away, drops in close again, and then heads back out. That's 11, 12, 13, 14, coming out back towards the Earth. So this was to test the systems of Orion, which is the spacecraft that we're going to be using to do the Artemis missions. It can carry up to 7 people, but normal missions it'll take about 4 people. And this was a complete success. First test ride, everything was fine. It performed admirably. The only thing that was a notable exception to that good performance was the fact that the heat shield ended up burning in a slightly different way than was predicted, and there were problems with how it burned. It never crossed any safety thresholds, and we were pretty certain that nothing would have happened if people were on it, or actually we were sure of it. But being NASA, we want to make sure, being a NASA vehicle, we want to make sure that everything is as predicted or as close to what we predict as possible. So when it re-entered the atmosphere and there was, it's called spalling, I believe. What are you looking at? You had some...
No.
Oh, okay. There were some issues with the heat shield that turns out where it's a little bit wrong in the way it burns. We've analyzed it, and that's why we're putting people on it now, because we've come to the conclusion that we've made some extra refinements to the heat shield, and it's going to be okay for this Artemis 2 mission. Here's a photo of the spacecraft from its own solar array on the back of this service module. This is the command module itself, the actual spacecraft, and then you can see the moon in glorious 4K. It's a beautiful, beautiful photo. And this is the rocket that it rode on. This is the SLS rocket, built off of the legacy hardware of the Space Shuttle era program. We've got the giant orange booster, reminiscent of the external booster tank on the Space Shuttle. And then we have the 2 solid rocket boosters, reminiscent of, well, the Space Shuttle solid rocket boosters. These are basically the same, just a little bit larger and a little bit more powerful. On the very top, you can see we've got this kind of cone coming up to the interstage, the second stage of this rocket. So we've got the boosters that fall away. This is the first stage, powered by 4 Space Shuttle engines, the RS-25s. And then you've got the second stage up here that actually propels it, it being Orion, all the way to the moon. And then you've got Orion on the top with the launch escape system. In case something breaks on the rocket, you want to be able to get away from the rocket in the middle of a launch. All the boosters are going, maybe the booster falls off or something like that. We don't want that happening, but just in case, they can get away. That's different from like Space Shuttle too. So that's going back to the safety and the safety-driven architecture that we had during Saturn V and the Apollo missions, where we want to make sure that no matter what happens, the crew's coming home. So here's another photo from the daytime of the Space Launch System on its launch platform. Really beautiful rocket, looks really nice. Some more information, yeah, the interim cryogenic propulsion stage, we've got the solid rocket boosters. 75% of the thrust of liftoff comes from those rocket boosters. Each RS-25 puts out around 650,000 pounds of thrust. That's 4 of them, but each of those boosters is pushing like 3.5 million pounds of thrust. Really, really powerful boosters, and that's how it gets off of the ground. Fun fact, this center booster is actually cut off and shut off before it runs out of fuel, because the way the boosters and the first stage combine, the boosters help get it off the ground. But once it's on its way, that first stage booster can almost get to orbit. They have to cut it off before, because otherwise you'll have a 200-foot tall piece of rocket just floating out there in orbit. We don't want that. So anyway, this is the capsule that we're talking about. This is the Orion spacecraft. It's a nice big capsule, much larger than the Apollo spacecraft that we took to the moon. Again, 7 people can fit on this thing, but normal missions, we're going to just put 4 astronauts. And it's designed, it was originally designed to go all the way past the moon to a distant orbit called a Lagrange point, which is a point in space where there's nothing, but the way the gravity interacts between the moon and the Earth, or just any 2 large objects in a gravitational system, that Lagrange point is where the gravity. Oh, thank God for MagSafe. The Lagrange point is where the gravity interacts, so that you can kind of station around that point, even though nothing is there. So this spacecraft was originally designed to be able to do that, to rendezvous with an asteroid. This is a remnant of the asteroid redirect mission, which itself was a remnant of past mission architecture, but we'll get to that in a different presentation. Today we're just talking about the fact that this thing can go far out from the Earth and loiter and stay on the area around, on orbit, wherever it is, for a much longer period of time than Apollo could. And so it's designed right now to be able to go all the way to the moon and stay around there for over a month, instead of just the 2 weeks that Apollo was designed for. So we're going to meet the crew. This is the crew for Artemis 2. They are currently in quarantine. They've already been delivered to the launch site, and they are going to be getting onto the rocket within the next couple days. This is Jeremy Hansen, the first Canadian to ever go into space. He will be also conducting his first ever space flight in general. So talk about great first flight, right? Going to the moon. This is Victor Glover. He is a pilot he was a pilot, and now he is an astronaut. He will be traveling to the moon. This is Reed Weissman. He's going to be the commander for the mission. Used to be the chief of the astronaut office, and now he's going to be commanding the first moon mission back in over 50 years. And this is Christina Cook, the first woman to ever go to the moon. She is also the record holder for the most amount of time ever spent by a woman in space, and will be adding to that time by going to the moon. Just really, really cool, awesome crew. They're very, very experienced, and they're going to be conducting a lot of really cool experiments over the course of their time on orbit. And here's some portraits from NASA. We've got Reed Weissman, Christina Cook. We've got Jeremy Hansen and Victor Glover. So these guys are going to be the first people to ever go back to the moon in over 50 years. Just really amazing, amazing thing. And this is the flight plan that we've got. So a little bit different than our Artemis 1 flight plan. We're not going to be going around the moon multiple times or staying on station, as it were, for more than a little while. We're not even going to really be in orbit around the moon. Artemis 1 actually stayed in orbit. This one is just kind of looping around. So we're going to launch from Cape Canaveral, or right here, starting at 1. We're launching from Cape Canaveral. We're going to do 1 orbit. We're going to boost into that orbit for about 24-hour orbit. So instead of being close in around the Earth, like the International Space Station or Crew Dragon or other manned spacecraft, Soyuz, for the first time in over 50 years, we're going to be pushing all the way out, almost to geostationary orbit, okay? Really far orbit, elliptical orbit, for the first time in a very, very long time with people. We're going to do that as kind of a test run to make sure that all systems are running, everything is okay, and then once we hit point number 9, we're going to light that engine up one more time to go into our TLI, Trans-Lunar Injection Trajectory. We're going to go over here, and after that TLI burn, we're going to jettison that engine because no longer do we need the engine, because we're now going to be in a free return trajectory. Free return trajectory is basically just We're lobbing this spacecraft out, and we don't need to touch it anymore. The way it will interact between the gravitational fields of the moon and the Earth, it will be able to loop around the moon with no burning of the engine, and then come straight back and land at land in the Pacific Ocean a few days later. The closest we're going to get to the moon is about 6,500 miles from the surface, so we're not going to even really get super close, but we will get close enough so that the astronauts can get a really good look at the far side of the moon. We're going to get eyes-on vantage points from all these astronauts, photos, cameras, live feed. It's going to be, well, far side of the moon, we don't have a communication satellite there yet, so not a live feed, but we will get some really great views. And again, first time in over 50 years, humans will be going to the moon. Like, that, can't say that enough. Like, that's like really important. Some of the things that they're going to be doing is this is like an Apple Watch. It's called Archer. It's basically going to be a little band that plugs into the systems on the spacecraft to monitor their sleep-wake cycles, their activity, their blood pressure, their heart rate, etc. Just monitoring how their body is responding to microgravity, 0G, over the course of going all the way to the moon. We've also got saliva samples, so they're going to be taking, they're going to be taking saliva samples both before, during, and after the space flight. And the saliva samples will provide information regarding their body's, like their immunity or their immune system and various other processes that are found within the saliva. And then this is a little chip called Avatar, and basically it's a brand new technology where it's tissue on a chip. This is a simulator for biological tissue where you can take this into space, and instead of having an animal or petri dishes or people, you can just take this chip and it will interact with, it will react to microgravity, radiation, to light, etc. in the same way that biological tissue would. And this will allow us to test whether or not these kinds of chips can be taken on trips to Mars, whether they can be sent on robotic missions, so that we don't actually have to send people on every single mission. We can just send one of these chips, and then we will get actual data regarding, how would a person's body react to that kind of environment. Remember, we're going way, way out of the electromagnetic field of the Earth, close in. We're not going to be protected or as protected by the electromagnetic field. So we're going to pass through the Van Allen belts where that collect radiation from the sun. We're going to be passing outside of those belts all the way to here, where we're going to be much more susceptible to solar radiation, maybe even intergalactic or interstellar radiation. We're not going to be under the protection. It's going to be like Apollo, but with much more in-depth analysis and much more ability to scientifically record what's going to happen to our bodies. So we need to go with a lot of this scientific gear so that we can gather all of that data. And where we're going, as we saw on that trajectory, we're not going to the near side of the moon. Apollo went to the near side of the moon, and obviously we can see the near side of the moon. We're going to the far side of the moon. We're going to the place that no one has ever laid eyes on, other than obviously the astronauts who went to Apollo. But for the first time, we're actually going to be able to take lots of photos and see it again in over 50 years. And that's all setting up. This whole thing is setting up so that we can continue with the Artemis program towards landing on the moon. That next flight is going to be Artemis 3, where instead of going to the moon, we're going to stay around Earth orbit and rendezvous with a lander. We're going to take the Orion spacecraft that is currently being prepped for Artemis 2, and we're going to take it into Earth orbit to dock with either the Blue Origin Blue Moon Mark II lander, which is Blue Origin's entrant into the moon race. They want to build this so that they can take it to the surface of the moon for Artemis 5 and 6. Well, Artemis 5. And then SpaceX, the current provider contracted to provide launch services for the lander on the moon and landing services on the moon. This is their version of a moon lander called the Starship Human Landing System, HLS. And this is basically a version of the Starship that we've seen blow up and land and take off and just be awesome for the last few years. Starship, as a system, as a design, is meant to be modular, meant to be able to be redesigned multiple times. And this variant specifically is going to have landing legs. It's going to have little engines right here. You can see, obviously we've seen Starship multiple times, but we've always seen it with just engines on the bottom and the fins on the sides. This one obviously won't have a fin set. It won't have a heat shield. It'll just have these little engines at the top so that when it starts landing, it doesn't create a crater at the bottom using the big engines. It'll use these engines, these maneuvering engines, to be able to land. And so the cool thing about this, though, is that Blue Origin's Blue Moon Mark II is designed to take a few people and about, I think, like 10 or 20 tons of stuff onto the surface of the moon. And it's pretty big. This is going to be about 40 feet tall, or I think like 40, 50 feet tall. It's going to be a pretty big piece of kit. But the HLS from Starship, or the Starship HLS from SpaceX, this thing is going to be a Starship variant. This thing is going to be 160 feet tall. It's going to be 30 feet in diameter, and it's going to be able to carry, technically Artemis is only going to stick 4 people onto this thing. But technically it has the same cubic volume inside, pressurized cubic volume, as an A380 airplane. So you can stick 100 plus people, 200 people, if you stick them in like sardines. You can stick a lot of people into this thing and land them all onto the surface of the moon in one go. You don't have to go multiple times. You can just, you want to staff a moon base with 50 people, boom. You can fit the moon base in there and the people at the same time, dump the rover out, and you got a functioning moon base in one launch. It's incredible. It'll be able to take about 100 to 150 tons to the surface of the moon, again, within the cubic volume of an A380. Like, really, really cool variant. But they have yet to actually get Starship fully functional. We'll see what happens. Now, this is a photo of all the Apollo landing sites. We've got 1, 2, 3, 4, 5, 6 landings between 1969 and December of 1972. Apollos 11, 12, 13, or 13 didn't land, my bad. 11, 12, 14, 15, and 16. Obviously, we have at Huntsville, Kennedy Space Center, and at Johnson Space Center, we have the remnants of the hardware for Apollos 18, 19, and 20, but those never landed. Apollo, you can see, landed mostly on the near, obviously all on the near side of the moon, but mostly near the equator and a little bit further up. Artemis does not want to rehash Apollo. Artemis is meant to be our bid to go back to the moon permanently, like long term. So instead of going to the equator, we're going to forego all of that. And we're going to go to the South Pole. This was released a couple years ago. There hasn't been too much information about where we're going to be landing right now, but these are our current primary landing candidates, or landing site candidates for Artemis 4 and 5, the landing missions. So you can see we've got Shackleton craters somewhere around here, but these are the big craters at the bottom of the moon. And the most important part about these craters and valleys is the fact that some of these craters you can see here at the South Pole are really dark in the middle, really deep, and really wide, which means that the bottom of those craters have never seen sunlight. Never, since they were created. That means that there is possibly water ice, chemical ice, other chemicals and minerals at the bottom of those craters that have not seen sunlight in billions of years, with a B. And that means that that water can hold chemicals that hold clues to the beginnings of our solar system, the way that the Earth and Moon were created. It can hold possibly the remnants of early life, depending on maybe something got launched over here, bacterium, who knows. We're going to go here to try and find out. And we're also going to use that water to build refinery stations for fuel, for food and water for astronauts who are living on base and exploring the area. Really, really resource-heavy place in this part of the moon, and we're going to go try and take advantage of it. Obviously, China is also thinking about going, and they're planning on trying to get there by around 2030. Our current schedule gets us there, fingers crossed, hopefully, around 2028, 2029. So a little bit of a race going on to see who can get back. But obviously, it's two different kinds of architecture too. China is not trying to get there with a huge lander, huge base. They're trying to set up for a base, but we're actually trying to get there with a ginormous lander. So different mission architectures. And that's what brings us over to Artemis 4. Artemis 4, now I crossed out 3, and we'll go over this in another presentation later on, but there have been significant changes in the last 2 months to the Artemis program. It used to be that Artemis 3 was going to be what we were going to use to go to the moon. However, due to the fact that Artemis 3 would be the first time we try, Jared Isaacman, the current administrator of NASA, and his team have decided that we're going to use Artemis 3 as just a rendezvous test, where we're going to stay in low Earth orbit and rendezvous the Orion spacecraft with a lander and try and see how that works. Artemis 4 is going to be when we actually attempt to land. Now, this is an old poster, an old mission plan, obviously because I crossed it out there, but the general idea is that we're going to be launching the Orion separate from the lander, and we're going to meet the lander either in low Earth orbit or in lunar orbit. Now, the old plan was that we were going to meet in lunar orbit in what's called a near rectilinear halo orbit, which is a very elliptical orbit, but it allows us to stay in contact with the Orion spacecraft for a much longer period of time. So instead of losing contact every 30 minutes for an hour every time it goes around the backside of the moon, it'll be going long way out from the moon and staying in contact with the Earth for a much longer period of time. It also requires a lot less fuel to get there for the actual Orion spacecraft, and the lander, since the lander is going to be bigger, they're going to be the ones with enough fuel to be able to get down into low lunar orbit and then land. So that's Artemis 4. Forget Artemis, or cross out Artemis 3 in your mind. But Artemis 4, this is the way that they're going to be using the HLS from Starship. They're going to be launching like 10 or 12 Starship launches to fill up a giant propellant depot, fuel depot up in orbit, where the HLS is going to dock with that and refill, right? It's going to dock with the fuel depot, or like come here and dock on the side, and it's going to refill so that it can be able to go all the way to the moon and meet up with Orion around in near rectilinear halo orbit, and then it'll land, come back up to NRHO, and meet with Orion and send everybody home on Orion. That is the Starship plan. The Blue Origin plan is slightly different, where we're going to be sending a refueler with the lander, and the lander will be always in low lunar orbit or high lunar orbit, and it'll be able to be refueled using this transporter that'll go between Earth and the moon. Now, these are old posters. This is from the concept of operations for Artemis 5 from like a couple years back. Really, everything has changed in the last month, last 2 months, really in the last month. So all of this is going to change, but the general idea will stay the same. We have 2 landers. We have 1 spacecraft. We're going to land on the moon, and we're going to use these landers and spacecraft to travel between the Earth and the moon in a much more sustainable, long-term way that allows us to build operations on the surface of the moon, on the South Pole. So like a moon base. Elon posted on his X Twitter page that he wants to build a mass driver. Like, lots of stuff is happening in the last month towards building that permanent presence on the surface of the moon. And this is how we're going to get there. And when I say we, I mean we. 60 plus countries are going to be part of the Artemis Accords as of now. The Artemis Accords are the agreement, the treaty that NASA created back in the early 2020s to combine the efforts and coordinate the efforts of all the countries, all the companies that are coming together to build the hardware, and also allow us to create treaties and accords that legalize and put in legalese what we intend to do as a species, not just as countries or as singular groups of countries, but as an entire globe dedicated to trying to get to the moon in a peaceful way, in a collaborative way. And that's what the Artemis Accords is as part of the Artemis program. So that's the Artemis program, and more importantly, that's Artemis 2 and what it means. It is the first big mission as part of this program. And we're going to be watching these guys take off on Wednesday at around 5:24, I believe, 5:24 p.m. Eastern time, so Central time, so around 6:30 Eastern time. And that's the first launch window that opens. It'll be through the beginning of, not next week, but the week after, so April 1st, around April 6th, I think. And then another launch window opens in late April, early May. But we're targeting, hopefully, the beginning of April. So keep your televisions on, keep your YouTube on, try and watch it. You know, you might get off work early, who knows. But yeah, Jeremy Hansen, Victor Glover, Reed Wiseman, and Christina Cook launching Wednesday afternoon to go to the moon, to do all of this, and start the process of all of these missions where we're going back to the moon and actually, like, we're going to stay there. It's really cool. I'm super, super happy to see it, and I think everyone should be super happy to see it. And that's kind of my presentation today. So, yeah, a little longer than I thought. But any questions from you guys? Because no one else is here. So.
Oh, I sent my questions into the YouTube chat.
Oh, really? I don't have any questions here.
Yeah, I posted one.
Oh, well, you can ask it because I don't see it on the chat here. So.
Oh, never mind. It's a joke.
Okay.
Question, don't worry
Well,
about
do you guys have any questions about the actual, like, mission or anything?
Not at the moment. I can probably think of a million things after we leave, though.
Well, I can tell you. So a couple of us here are car guy. Oh, what question?
Do you think SpaceX will actually be able to deliver on Starship?
Okay. So the question for those on live stream, if you guys didn't hear it, will SpaceX be able to deliver on Starship? So obviously in the last 5 years, just to recap and context, Starship has had some very high profile, let's say, incidents where it has blown up. They've done 11 flight tests. Most of those flight tests, or a lot of those flight tests, I don't know if it's most off the top of my head, but a lot of those flight tests have ended in explosions, either by the booster or the spacecraft. The spacecraft doesn't reach orbit or reach its intended near orbit. It never tries to go for orbit. It always goes for a slightly less than orbital trajectory. And sometimes it doesn't match it. So I don't know. I think that question, like the architecture and the idea of it is very difficult. But obviously SpaceX has proven that they can do things that a lot of other people think are impossible. So I think that it's not completely out of the realm of possibility. The real question is whether or not they can get their flight rate up, because everything can be solved. I mean, essentially Elon, because of his magnetism for venture capital, they have a blank check. They have Starlink funding, they have commercial launches, they have government contracts. They basically have a blank check that every launch is $200 million, give or take. They've done 11 of them. So that's what? It's 5, so that's like just over $2 billion just in launch costs that they've spent. And the program itself has probably taken about $10 billion. But the rumors if the rumors for IPO, that they want to go for IPO for SpaceX in the next 6 to 8 months, if those rumors are to be believed, a lot of people think that the valuation of SpaceX is not in the billions, but $1.5 trillion. Now, obviously, that would make it the most valuable private company in the history of the world, and that's, of course, all just paper, right? It's on paper value, but like they have a blank check, and to be frank, the idea. Starship itself is basically the linchpin for the entirety of the future of human spaceflight. Starship itself would enable all the things that we want to do: mass drivers, huge payloads to Mars, huge payloads to the edge of the solar system. Other rockets are capable of doing something like that. New Glenn's new variant that they proposed about 3 months ago, it will get to that, almost to that capability, about like 60-70%. But, yeah. But, that's what, again, back to the question, whether they will make it. I think we will have to see based off of the next 6 months. The next launch will be for SpaceX, for Starship, is rumored to be mid-April. They've done, and I'll go over it in a different presentation soon, but Starship, I was going to include it on the news here, but I didn't have too much time. Booster 19, the first version 3 booster, Block 3, and the first Block 3 Starship 39, are already built on the pad, tested, and they're waiting for final integration so they can start trying to launch it. So that launch should happen, and based off of those launches, based off of the success of Block 3, they've done Block 1 and flights 7, 8, 9, 10, and 11 were all Block 2 versions of Starship. So now Block 3 has all the design iteration and improvements from the first 2 versions integrated into the spacecraft and the booster. So hopefully it succeeds. But, there's still refueling that needs to be done. We actually need to get Starship into orbit. We need to test whether or not Starship actually makes it to lunar orbit. And most importantly, they need to actually show that they can actually build the lander. They haven't actually shown anything of the lander so far, other than interior shots, renders, and some hardware. So if we see hardware for the HLS within the next 6 to 8 months, if we see version 3 succeed on its first few test flights and actually be able to launch and achieve all of its mission milestones, I would say I'm optimistic, cautiously optimistic, that they will be able to make a timeline of end of 2027, be able to go for the moon and send something to the moon. I think that's not completely out of the realm of possibility. Whether or not they put people on it, though, I mean, too early to tell. I think we got another one.
Yep. The question is, how long is Artemis 2 in days?
How long is Artemis 2 in days? So let's go to the mission trajectory here. Let me check here. I don't remember off the top of my head here.
It looks like...
It doesn't show. Oh, that sucks. Okay. Actually...
you can add it up based on what's on the poster, because return...
Well, this is a 24-hour thing. I believe it's only going to be...
Yeah, but look, travel time is approximately
4 days
for return
right.
to Earth. There's a 23.5-hour checkout.
Oh, so about 2 weeks.
Yeah.
So about 2 weeks. It's going to be about the same time as an Apollo mission. But in this case, no landing. So, not too long. They're not going too far away. And let's see. Yeah, any other questions? Yeah, it's not going to be too long.
Yeah, there's just one thing I've been wondering about spaceflight in general. It's like, how do you make so much fuel?
So much fuel. So the rocket runs off of liquid oxygen and liquid hydrogen.
Oh.
So liquid hydrogen hydrogen itself can be made in a variety of different ways. You can, most of the time, as far as I've heard, you can get hydrogen based off of the off-gassing of oil wells. They refine it based off of the gases that come off of oil refinement. And you can also get it through,
Hydrolysis?
Yeah, out of water. They break apart the oxygen and hydrogen in the water, but that's extremely power intensive and highly inefficient in terms of power. So, variety of different ways. But this rocket, SLS, the booster itself, so let's go back. Let's go here. So the booster itself, with 4 RS-25 engines directly from the Space Shuttle program, literally plug and play. Those run off of hydrogen as the fuel, and the oxidizer, because in a rocket engine you can't, jet engines breathe the air to burn the fuel, right? But obviously you can't breathe air in space, so we bring the oxygen with us. So the liquid oxygen is the oxidizer, the fuel is the hydrogen, and they combine to throw out, fire, right? The solid rocket boosters, on the other hand, they're solid. I don't remember off the top of my head all of the different chemical components, but it's just another chemical synthesis. And, it's a lot, but it's just another, chemical process. So getting all of that fuel is not actually that difficult. It requires technology, it requires effort. Liquid versions of that fuel, obviously, oxygen is plentiful. Hydrogen is plentiful. Getting it, a little harder, but not too hard. Keeping it liquid, liquid oxygen is like negative 190 degrees Fahrenheit or something like that. Liquid hydrogen is like close to absolute zero. Like you have to, fun things about liquid hydrogen and liquid helium. To those kinds of liquids, metal solids are not solids. Like you can have a container of liquid hydrogen and it will literally seep through the metal. Like same thing with liquid helium. Liquid helium is actually a fun little liquid. If you keep it in a beaker, liquid helium will actually travel along the walls and come out of the beaker all on its own. It's really, really crazy. Like working with these kinds of liquids, liquid gases, is extremely difficult. So that's why a lot of people don't like working with, a lot of companies don't like working with liquid hydrogen, is because it's just bloody difficult. It's really, really, really difficult. So that's why things like Starship, so if we zoom over here, so Starship HLS, it runs off of liquid methane and liquid oxygen. So the liquid oxygen is still the oxidizer, but liquid methane is what we use as the fuel. And liquid methane is much more easily synthesized on extraterrestrial landing zones. That's why it was chosen, because originally Starship was supposed to go to Mars, and it's much easier to make liquid methane on the surface of Mars than it is to make liquid hydrogen. And it's also much easier to contain too. Not as cold, it's not as voluminous. Liquid hydrogen requires a lot of volume to keep. Liquid methane doesn't require that much volume comparatively. And while it does not, liquid hydrogen and liquid oxygen are highly efficient when burned. That's why the space shuttle used it. So efficiency in rocket engines is called ISP, specific impulse. And the higher your specific impulse, the better your efficiency is with regards to the amount of fuel you're using and the force, the literal force of the combustion reaction coming out the back. And it all depends on how fast the exhaust is moving out the back. Hydrogen being super light, you can move that thing really fast. So the ISP of a liquid hydrogen engine is like 400, it's measured in seconds of specific impulse. You can get like 400 plus seconds of specific impulse in a liquid hydrogen engine. But a liquid methane engine is more like 300. But it's enough, and you can produce enough power that it doesn't matter. Like your efficiency may be lower, but you get enough power and you're getting enough of the engine, like you're getting enough efficiency, maybe not the most, but you're getting enough that you can actually make the design work. So to make that fuel, it's a good question. And that's partially why we're going down to the South Pole, is because, some of these spacecraft do run off of liquid hydrogen. I believe Blue Moon Mark II may actually be running off of liquid hydrogen and liquid oxygen. You synthesize that based off of the water ice at the bottom of the moon. You've got a liquid fuel supply or a frozen fuel supply down there for hundreds of years of launches off of the moon. And more to the point of why we're going to the moon. We're going to the moon because of that question. How do we make fuel outside of the planet? Because obviously if you need to come back to home every time you want to build a rocket and launch it, we're never going anywhere. So the point of going to the moon and building a base, the point of doing a mass driver, the point of creating space stations is so that we can have bases outside of the planet that can build, refuel, maintain, and spread human exploration across the planetary system. So the bottom of the moon with a mass driver, we'll get to the end there. With the fuel down there in ice form, liquid or frozen water ice and various other chemicals, you can synthesize your fuel and create, using the Blue Moon Mark II, you can have landers that go from there to a space station in orbit. Or more importantly, you can deliver goods and services from the base to an orbital shipyard. It's much, much easier to move things from the surface of the moon to orbit than it is from the surface of the Earth to orbit. So if you build stuff on the surface of the moon and then deliver it to orbit around the moon, you now have taken out a ridiculous double-digit percentage of the amount of fuel that you need to get from the Earth-Moon system to Mars. The delta V, the amount of energy required to get from the moon or get from Earth to Mars, is say 100%. 80% of that delta V is spent getting to the moon. After that, it's a much less amount of delta V. Now, I don't have a calculator on me, and I don't really know the calculations to actually give you the exact numbers, but leaving from the moon to go to Mars is a much better proposition in terms of fuel and energy requirements than it is from going from the Earth to Mars or anywhere else in the solar system. So that's a huge question. How do you get all this fuel? And part of the answer is the reason why we're having Artemis go to the South Pole, is so that we can get the fuel, we can get the materials, we can get the personnel to be on station and ready to go to enable long-term missions past the moon, past Mars, going out towards Saturn, Neptune, Uranus. Some of these spacecraft, especially HLS, Starship, fully fueled, the Starship spacecraft is able to do a flyby, maybe not landing, but is able to do a flyby of Saturn. A round trip to Saturn is probably around 8 years. But to do it in a Starship, you could probably get it down to around 7, maybe 6 years. Which means that if you can build a moon base, if you can build a space station, a logistics network from here to the moon that enables a fully fueled Starship to leave from the moon, you're not talking about, as I said, that is the pressurized volume of an A380. So we're not talking about sending an Apollo era, 3, 4 people over to a long-term mission, or 6 people. The Martian, the movie, had 6 people go to Mars in a multi-billion-dollar spacecraft, $150, $200 billion spacecraft. One Starship could take 20 people and keep them alive for a year, maybe years at a time, but depending on the life support system. But you could take a team of 12 or 15 people or 20 people, artists, scientists, engineers, on a trip with 2 or 3 other supporting spacecraft to the surface of Titan to explore an extraplanetary moon or an asteroid. You want to go to the asteroid belt past Mars? You can visit Ceres, the largest asteroid dwarf planet in the solar system. You can use one of these or a few of these in conjunction as like a fleet of spacecraft heading out to conduct a massive multi-year science exploration based off of a moon base. That is what we're trying to do. And that is the intention of building this kind of program. And that's what's cool about Artemis, is that we're actually trying to do it, not just trying to land. So, and then, sorry, that goes more towards what Elon was also pointing out, which a lot of space nerds are hoping and praying for, is that the end goal, the end game of going to the moon is what's called a mass driver. A mass driver is essentially a railgun. It's a giant magnetic accelerator that will accelerate a payload into orbit. So on Earth, you use a railgun. It fires a projectile at Mach 8, okay? Thousands of miles an hour. But we're stuck in a soup of atmosphere. You can't get out. And you also have the gravity of the Earth. The moon is 1/6 Earth gravity with no atmosphere, which means that if you have a magnetic mass driver accelerator, you can launch not maybe like this, which is 150 tons from the surface of the moon, but one of these launches every few hours, right? At the best, right? You can have a base on the moon launching one of these a few times a day. A mass driver, because it requires no fuel, it just requires electricity, and because the payload is basically a container, you can load a container on there every few minutes, not hours or days. So once you can get enough of these and a big enough base and enough people to build a mass driver, you're able to deliver all of the aluminum on the surface of the moon. The surface of the moon is basically just aluminum. It's rock and aluminum and lithium, which means that you can create alloys from that. You can build spacecraft out of that. So you want to build a Star Trek Enterprise level kind of ship. You want to build a ginormous ship around the orbit of the moon. That's the best place to do it. Because if you have a mass driver, you're not delivering things every few weeks from the moon or the Earth through a rocket. You're using a mass driver to deliver everything every 5 minutes. 10 tons, 5 tons of material every 5 minutes. Like it's basically a conveyor belt into orbit around the moon. And you can build massive orbital shipyards, massive ships within those shipyards. Stations. You want a gravity station, a kilometer wide, so that people can actually have centripetal force, simulated gravity, or even half gravity to fight the effects of 0G, where you have muscle degradation, bone density loss, your muscles, your brain is affected. Literally, we just had a Crew 11 medical emergency on the International Space Station, the first time in history where someone had to come back emergency from the International Space Station. And that's because in space, the fluids in your body, the pressures are all involved and going haywire. Your body is not designed to be in free fall for long periods of time. So if you can build a space station, if you can build a mass driver on the surface of the moon, you're now enabling the construction of massive ring stations where you're not talking about hundreds of people on a ship. You're talking about tens of thousands of people working and building things in space, building out the TV show, The Expanse, or Star Trek, Star Wars, those kinds of like science fiction universes where you're building things in space. That is what's capable of being done with a lander like this, with a mass driver, with a base on the moon. And that's what we're trying to shoot for. At least that's what all the space nerds want. And it all comes down, I guess, to those kinds of questions. Sorry, to bring it all back. How do we get the fuel? How do we get the materials? How do we build things outside of the Earth? Big spaceships. So, anyway, thanks, guys. I'm going to probably just wrap it up, unless you guys have any other questions. Anyone have a question? Anyone want to throw out a joke question? Crazy question?
Yes. Why is NASA hiding the truth about aliens on Mars? You've seen the Antarctic meteorite. You know it. You know.
So the question is, why is NASA hiding the truth about the aliens?
I want to believe.
You know what the real answer is?
Yeah.
Because you can't handle the truth. And with that, I'm done. I'm done today. I did my Few Good Men.
You ever heard of the knife alien?
I don't care. You can't handle the truth, all right? Anyway,
you heard that
thanks, everybody. A little bit of technical issues, but you know what? It was fun. We'll fix it in post. I'll see you guys on the next presentation, and make sure and catch that Artemis 2 launch this Wednesday at around 6 p.m. So just stay up to date with NASA posts on Twitter and all that. Anyway, have a nice day.